Okay, here we go with Unit 6. Unit 6 is a fantastic unit. This is all about integration, or in other words, antiderivatives. That's how they kind of introduce it, as antiderivatives. So what we have been doing is derivatives, and now what we're going to do is we're going to kind of reverse engineer the process, and we're going to go with antiderivatives. Let me start you off with like one of the basic ideas of antiderivatives. All right, so let's take a derivative actually first. So say, for instance, I have 5x to the third. So pay attention to the process about what we do when we take this basic derivative. So the first thing that you do is you multiply, right? You multiply that exponent and you create, for instance, in this case, you create the 15. Okay? And then the second thing that you do is you subtract. So you subtract 1, bringing that down to create the 2. So the first thing that we did was we multiplied, and the second thing that we did is we subtracted by 1. Hooray. Now, an antiderivative is the exact opposite of everything that we just did. So we go in reverse order and we flip the thing up. So in an antiderivative, the first thing that we're going to do is worry about that exponent. Okay, and when we subtract it by 1, we're going to add 1. Okay, so this, again, the second thing that we did was subtract 1. So the first thing that we do is add 1. And then to the coefficient, we multiplied, then we divide by whatever it is. Okay, so the first thing that we do is we worry about the exponent. The exponent is now 3. Fine. All right, so the first thing that we do is we add the exponent. We worry about the exponent first, and then we divide by what was ever there. So we divide by 3, and thus we come up with this 5. And so we know how to do a derivative, and then we can do an antiderivative. So again, at another example, 3x to the 4th. Okay, so if I'm taking an antiderivative, the first thing I do is I worry about that exponent, 5. And then in essence, what I'm doing is I'm dividing this up front. There was a 3 already there, so it'd be 3/5. So worry about the exponent first. Where you take the derivative, you worry about that multiplication first. You bring it down first. Here, worry about that exponent and adding it first. And again, it can kind of get a little convoluted when you come up with, negative exponents and things like that. But again, the process is just the same. So let's say we had 1 over x to the 4th, or AKA, that is the same thing as saying x to the -4. Okay, not a big deal. So taking the antiderivative, that we add 1, so that would be -3, and then we divide it out. So this would be -1/3 on the division. And again, now, if you get your answer and you say, oh, I'm not sure if that's the right answer or not, I'm not sure. What you do is you take the derivative of that. So -3 times -1/3 is 1, and then you subtract 1. And then what do you know? You should start off with what you began with. Now, the last piece of equipment that I kind of have to talk to you about is when I take an antiderivative, like I did right here, what you have to do is you have to add a generic constant. It's plus c. Because what can happen is this c can be literally any number that you want to make things work. Like, so this number could be, like, for instance, the number 6. The number 6. If I take the derivative of this, notice how when I take the derivative of 6, it just goes away. So who's to say that that 6 didn't exist once upon a time? So again, if you take an antiderivative, what you do is you take the antiderivative, so you do all the hard stuff, right? And then what you do is you add this generic plus c at the end. Let's go ahead and get to some problems. So here, we increase the exponent, and we divide. So divide by 2 makes 1. Hooray, add your constant. Okay, here we go. Add 1, divide down. Hooray, add your constant. Okay, and you can do this in addition and subtraction. Like, warning, there is no product rule, there is no quotient rule, so if you see multiplication with things that you need to take integrals of, stop, pause, and you got to think real hard, because there is no product rule, there is no quotient rule for us right now anyways. All right, so here we go. The x squared, you add 1, divide down. Okay, that middle x, you add 1, divide down. That 1, you add an x. So there isn't an x, so there is now. And then there isn't anything to divide, and then your constant. Yeah, I should have kind of mentioned that also. Notice how constants, they gain x's. So like if I take a derivative of 1x, it turns into 1. Okay, here we go. Add 1, so that's a -3. And then divide down, so that turns into a +1. Add 1, divide down, add your constant. Okay, in these problems, it's probably in your best interest to rewrite them a little bit. Okay, so rewrite them. That allows you to work with the exponents a little bit easier, and then you can fix it at the very end. So notice how that -5 turned into a +5 because I divided by a -1. So again, it's probably in your best interest to rewrite these. So when I divide by this, so when I see that I have an x to the 3/2, what in essence I'm doing is I'm multiplying by a 2/3 to the, the 3/5 that is already there. So it's multiplying by a reciprocal, right? That's a division of a fraction. It's a multiplication of a reciprocal. So you'll see some of this kind of action taking place. So this ultimately will be 2/5. So this is a division of a 3 and a multiplication of a 2. So this is, again, a multiplication of a 2 and division of a 3. because that'll be 1. Sorry. And again, if you're confused on, you're worried, hey, did I do this right? Do I have the right answer? So if I take a derivative of this, okay, it should turn back into the original problem. If it doesn't, you did it wrong. All right, now, here we go with sines and cosines and things like that. When I take a derivative of something, like say I'm taking the derivative of sine, okay, that turns into cosine, okay? And if I take the derivative of cosine, that turns into negative sine. Now you got to think of this backwards. So what's the antiderivative of cosine? It would just straight up be sine. So the question is, what is the antiderivative of sine? Okay, it would originally be negative cosine. So I know you're used to in derivatives where sine goes to cosine and cosine goes to negative sine. In integrals or antiderivatives, you got to think of that backwards. So a sine will create a negative cosine. A sine will create a negative cosine. A cosine creates a regular sine. Again, if you don't get it, think of the derivative. Okay, so for here, what does the sine go to? It goes to a negative cosine. Now think of the derivative that's going to be created by this, cosine 3x. So the cosine goes to negative sine, and then there's going to be a chain rule. There's a 3 coming out. So, but I can't have that. I need that to be a 1. So what I need to do is I need to counteract that with a 1/3. And then the ever important plus c. So sine is going to go to negative cosine. There's a 3 there, so the 3 gets to hang around. Nothing moves it. So again, the derivative of that would be positive 3 sine x. There it is. Okay, so negative 3 cosine. And then this goes to a positive cosine, and then I counteract the 3 plus c. Again, sometimes it's like writing with a crayon when I'm using this marker, so I kind of run out of room. All right, what creates a secant squared? That's a tangent. So this is going to be a tangent 5x. The derivative is secant, and it multiplies out. So there it is. Oops, sorry, I forgot the plus c. So that's secant 5x, chain rule 5. So it creates that outside 5. It's all good. So tangent 5x is required. That's going to create a 5. I don't want the 5, so I have to mark 1/5 back then. What creates a secant tangent? That's a secant. Again, thinking of what creates that as a derivative. That's a derivative of what? All right, and so again, this is basically a secant 2x. That's going to create a chain rule 2, so that one's all good. So a secant 2x, that's going to create the secant tangent portion of the answer, but it's going to create an outside 2. I want that to be a 4, so I need to multiply by another 2. Okay, this one, it's kind of a trick question. You need to do a little bit of math before you're able to do this. Again, right now we're not equipped to do the chain rule or the product rule or anything like that, so we can't really have this. So let's square this. So just straight up right now, this is sine squared minus 2 sine x cosine x. Plus cosine squared x. All right, some trig things that I can do. Sine squared x plus cosine squared x is 1. Okay, and then the one that they give you right here, 2 sine cosine is equal to sine 2x. So this has a minus on here, so this is a sine 2x. That is the logic behind that right there. Okay. So this is what I have right now. And so the antiderivative of that, this goes to x. Sine goes to negative cosine, so that's going to be a positive cosine 2x. That's going to create an unwanted 2. On the derivative of this is going to create an unwanted 2, so I have to put a 1/2. So when that 2 does come out, it gets eliminated. Okay, suppose 1 minus square root of x is an antiderivative of f, and then x plus 2 is an antiderivative of g. Find the general solutions. Okay, so the antiderivative of f is 1 minus square root x. Not a big deal. The antiderivative of g is x plus 2. Negative f is just going to be negative 1 minus square root x. So what this is saying is you can take the antiderivative and then the negative is just attached, in essence. How we're going to learn this later, this is going to be the negative integral of f. Okay, so this is what it's going to look like eventually. So just hammering this out, this would be the square root of x minus 1, just to make it look pretty. Okay, these do not get plus c's because they already have constants attached to them. So they are already saying that is the antiderivative, so don't add your plus c. Keep this up there. So g is x plus 2, so this is negative x plus 2, so this is negative x minus 2. F, and so you can add these things together. So what we're going to learn is if I have f plus g, this is the same thing as going to say f plus g. This is what it's trying to teach you. So f is 1 minus square root x. G is x plus 2. So I can put the 1 and the 2 together. So this is going to be x minus square root x plus 3. All right, so here this is kind of a combination of above. So 3f minus 2g. Okay, so what this is trying to teach you is if I have, the integral of 3f, Okay, that is the same thing as saying 3 integral f. Again, we're not quite there yet, but we're getting there pretty close. So 3 minus 3 root x minus 2x minus 4. And so this is going to be negative 3 root x minus 2x minus 1. These up here so I still know what I'm talking about. So x, that's the antiderivative of x right there. And then plus f. I don't think anything combines. And then g minus 4x, that's the antiderivative of that. So this is negative 3x plus 2. Okay, so here they give us the derivative. So if I take the antiderivative of that, that means y is going to be equal to x squared, 1/2, and then plus c. Now notice that, oh, this one's obviously the incorrect answer, but notice that both of these are, in essence, x squared graphs. These are both x squared graphs. Which one is correct, though? And so this is where this quote-unquote initial condition comes into play. This says when y is equal to 4, so what I do is I go down to my derivative. So they tell me when y is equal to 4, x is equal to 1. What this allows you to do is solve for this mysterious c. So this is 1 plus c is equal to 4, thus c is equal to 3. So what was this equation actually? This was y is equal to x squared plus 3. That is the equation. Which one says exactly that? Which one is x squared plus 3? That would be option B. And that's it. It's your introductory episode of antiderivatives. Again, the general idea is take the exponent, add 1, and then divide down.